Okay, please, are we okay? Can we move on? As for the plot, we'll come back to it. All what I want you to check is that, well, we can have plot and be able to talk about the data set and so forth. Then we can move on. So is everybody okay with the descriptive statistics? So what we have done over here, we can also use describe to get the characteristics for each of these, right? So we want to compare the losses for those who were represented by attorneys and those who were not. So what do? Well, remember the describe, there is described by summary statistics by group. I think there are two, report basis summary statistics by grouping variable. So whichever one we want to use, we will be able to. So describe by, let's see. So any of them is right. Describe by X, then group. So here, X is a data frame or a matrix. So these are the reason why we took time to look at data structures. So you want to use describe by, then it is telling that X should be a data frame or a matrix. So if you don't know what a data frame or a matrix is, then it becomes a problem. You go and put a vector there, it won't work. Is that okay? Good, okay. So now, let's see. Then, what else? Let's go to, yeah, but I can use this. Okay, what am I going to use? A vector, but it will work. So describe by my X will be auto BI loss, then group will be auto BI. Oh, sorry. Attorney. Okay. So this is how it looks like. I want it to follow each other so that you can compare. Good. So here, it's like we want descriptive statistics to help us compare the losses incurred by those who were represented by attorneys and those who were not. Right. So the first, you see X1 variable 1, variable 2. So we have group 1 and group 2. The first group, there were 685. And the second group, there were what? 655. So the first group were those who were represented by what? Attorneys. So look at the average, 9.86. Look at the average for those who were not represented by attorneys, 1.86. Now here, if you remember, I talked about standard deviation. When it is just one variable, all we know is that the smaller the standard deviation, the more closely related are what? The values. Or the values are not widely dispersed. Good. Now if you look at the two, what we are saying is that those who are represented by attorneys, there's large variability between them, the values, compared to what? Those who were not represented by attorneys. This is what you see in the graph. Remember, we had that one, that red value way high, and so forth. But in the one that were not represented by attorneys, you realize that the outliers were not that distinct from the majority of the data. Please, is everybody okay with this? So these are some of the things you look out for when you want to analyze data. The median. You see this one, the median is still what? Way larger than that one. Yeah, if we even trimmed the mean, it is still larger. Mean absolute deviation still larger. Minimum. So the other one 0, this one. Look at the maximum. So this one, those that are not represented by attorneys, the maximum is 82. Look at the maximum for those represented by attorney, 1,000 over 1,000. Of course, then the range will also be like that. Skewness. So, in terms of skewness, group 2 is highly skewed than the other one. Now, and this is so because of, let's say, the graphs, if you look at it, because they were on the same they are on the same graph, so you don't really see the extent with it. But this one, it is highly, if you look at this one, the mean was what? 0. No. The mean was 1.86. From 1.86 to 82, in terms of percentage wise, that will be more than from what? 9. Well, we need to check it properly. But if you, how do we demonstrate this? Maybe let me use a histogram to see how. Well, okay. So, but what are we looking at? The skewness, is it? Oh, sorry. I was comparing them wrongly. So the skewness, this is 118.64 and this is 14. I was comparing with 274. Sorry. That's the ketosis. Okay, so in terms of even the skewness, that is, yeah, so that's what I was trying, but there was a contradiction. From 186 to 82 is not more than from 9.86 to 1,000. Yeah, so this still will have a higher skewness than that one. Yeah, and that's what we are seeing as 18.67 compared to 14.08. And of course, it has a bigger ketosis as well than this one, almost twice. And so forth. Please, any question on that? So that's how we can do comparisons with it. So now let me let you also try this. So I want you to compare. Let me go back to the data. Let's look at the marital status. So let's look at losses in relation to their marital status. So let's compute descriptive statistics on losses incurred by the people. But now we want to check it in relation to their what? Marital status. Are those that are married, do they incur more losses than those who are not? Or those who are divorced and so? which marital group became all losses? Which group became more losses? Four groups. So collapse this side so that you can see all of them at which group incur more losses? Which one? So you can also use these statistics to tell the marital status among the group, right? Okay, so the egg will tell you, you can even compute percentages without. Which groups are in the majority? Single. So how will you communicate it? So let's see, that's it. Group one is all single. And then group two. So you have to go to the home. So group two is what? And group one, married. Group two, group three, group four. Okay, so which groups are in the majority? Single. Now, how would you communicate it? Let's say we are doing a writer. We have to write about the composition in this. So can we get somebody to tell us what you will write? Yeah.
It's group one.
What is group one? One is married.
2 years. One is married.
Okay. So how many people are married?
689.
689. Which one? Yes. Ask how many people are married. But we want to communicate the marital status composition in this group. So how do we go about it? You have the values, so let's see. Yes. Yes. Okay, so it looks like this. So 1 is 624, then you have 650, then group 3 15, group 4 35. So how are you going to communicate this? Yes, I want the narrative because that's the main thing we want to. You have this. How do you communicate this? They are different, yes. How would you communicate? There are 4 groups. One is 624, one is 650, the other 15, the other 35. How are you going to communicate this?
Claimants who are single incurred the most economic losses as compared
How do you determine most?
by the number of losses that is stated. Well, the loss number, not size.
Okay, related to, okay. So the group 2 is which people? You said
2 is single. So
single, okay. So how are you? Let's write. I think everybody should write down because we are wasting time. Right. Just on the end, the sample size. How would you communicate this? That's the,
based on the sample size.
yes, just a sample size. So the sample size gives you the composition, the marital composition in this group. So how would you communicate that? Remember when you are doing statistics, this one we could use a bar chart or whatever to represent them. How do you communicate? That's what I want to.
Okay, so would you like us to draw a chart?
Is whether a chart or the numbers, how would you communicate this? So you have to write a story about this. There are 4 groups or 4 divisions of marital status in this data. Then go on. So some, you may look at it from the minority group, or you may also look at it from what? The majority group. So if you look at it, group 1 and group 2 will constitute almost 98%, if I'm not. Yeah. So you may say that almost all the claimants are either married or what? Single. Okay. Alternatively, you can go ahead and calculate the percentages. Remember, they are all 1,340, right? So if you divide 624 by 1,340, you get some 40 something. Then 652, 40 something. And so forth. So you can also communicate with what? Percentages. What you should not be doing is to say that maybe 48% of the, no, 48 is too much. Maybe 45% of the claimants are married. 44 are single. 1% are divorced, and then it's like you are walking through the data. You are telling us the same story that we see from the table, but you have to put interpretation in the on the values you are looking at. So if you say almost all of them are married, either married or so then you can now zoom in and say that maybe the percentage, those that are married are 3% more than those who are not who are single. So you see, I'm not quoting directly the values, but once I give you one and I give you the percentage difference, you'll be able to tell me the other one. So that's the sort of tricks we use in analyzing data. So, and the same way, as I said, you can also look at it from the minority group and lump them together. So you have 35 and 15. That's all. 50. That 50 will be maybe 1% or something. I think less than 1%. If you divide 50 by 1340, that will be less than 1%. Right. Or is that the case? Good. So you can also say that less than 1% of the claimants are 3 and 4 is what? Group 3 and 4. Yes. So you can put them together. Then the rest are what? Married or single. And out of these, they are almost apart with, they are almost apart in terms of percentage with maybe those that are single slightly ahead in terms of percentage. In that case, you can also just use the difference, as I said. That one will not quote directly the percentages in those groups. So that's a sort of strategy you use in analyzing the data. Is everybody okay with this? Okay, good. Now let's move on. So this one, we've not talked about size. We are only talking about number of people within each category. Then when we move on, we have mean. What can you say about the means? What can you say about the means? So in this case, you don't have to walk through the data as well. You can pick the maximum and the minimum, and that's enough. But they are just 4. So group 1 seems to have all the highest or the largest average losses. And that's almost like one is like a one compared with group 4, the difference is just around 1, right? And of course group 3 has the lowest average. Which one is more variable? One, yeah. Because the standard deviation is quite high. So this one, you can also look at it that the standard deviation for group 1 is almost like 4 times, at least 4 times the rest. Is everybody okay? That's an interpretation. That I'm not calling anything. I've not even called any number. I look at it and say, if you look at the closest one, that is 12. So it's almost 4 times that one. Yeah. And if we look at group 3, that's even more. So once I use at least, it caters for all of them. Yes.
So I was trying to compare the means with the number of claims.
Yes.
Is it right if we say that for claimants in group 4, which is those divorced, although they have a lower number of claims,
Yes.
they have a relatively larger size of losses?
Which one? The
Claimants in
group 4. Yes. Yeah. So you it's up to you when you are analyzing data. You can look at it and find peculiar points that you can look at it. That's why if you give data to 2 different people to analyze. You realize that of course, it depends on how you want to look at the data. But if you look at it like group 4, well, group 4, they are very small values in terms of number of people. But you realize that the average claims are quite high. It's almost second compared with the others. Okay, so that's also a legitimate point to raise, and so forth. Now look at the medians. So you see that the median, it doesn't follow what we got from the mean. So in this case, you can even contrast them and say that even though, so look at the group 4, as you said, look at its median, 3.85. That is the highest. Is that okay? So even though it has the second highest mean, in terms of median, it's at the top. Okay, and what can you say about that? What can we say? Now, if you look at the mean and the median, we already have the skewness, but all the means are all larger than what? The medians. So that's also a point. So if I did not even have the skewness, I could have interpreted this to mean that all of them are right skewed. And if you go to the skewness, you realize that they are all what? Right skewed. And of course, in terms of skewness, group 1 is the highest, right? And that is so because if you compare the mean and the median, they are wide apart compared with the rest. The farther the mean is from the median, the more skewed the data will be. So, large skewness is relative, or it's directional. I should. So, if the mean is on the far right hand side, we expect that there are very large, unusually large observations, so it will be skewed to the right or positively skewed. If it is also further away on the left, then it will be what? Negatively skewed. So, okay. And in terms of, so basically that's what, and then the maximum, you can also talk about it. So if you look at it, the first two exhibit what? The first one exhibits large variance or range because of the maximum and so forth. All right, so that's it with this. Let's see. How do you? So the other way to look at this is also through the plot, right? So let's copy the box plot. I will explain what I think you did box plot in your stuff, or did you do so? Not yet. Didn't you do plots, box plots? Yes, that's what I want to hear. So you have done it. So let's see. Instead of describe by, we replace it with what? Box plot. So here we are going to get graphs. Oh, okay. I need as a function of what? Oh, so I don't even need all this. So the box plot can take loss and marital status and not group, but this should be what? Data. Or to be here. Formula, let me see. Okay, yeah. It's not X, but formula. So I can take it off. Good. Okay. So you don't really. The data is so skewed that you hardly see what is going on. You can't even see the color. So 2, 3, 4. Oh, it should be 5. Because they are 4. You can't even see the color. So these are the box plots. You see that one has the largest values and it goes down like that, but it's not quite pleasant. Which one is not running? Let it run. No, you can't see anything. Okay. So this, what we are seeing here are just what we did witness in what? In the graph. Sorry, in the descriptive statistics. Group 1 had more variation, and that's what you see here. This is here, so you see the range will be so high. This one, it follows that and that one. So basically, this is how we do box plots, right? So we've seen box plots, we've seen histogram, and so forth. So next, when do I meet you again? Wednesday. By the time I meet you, you are proposing. I'll send you videos of so we have to be doing these graphs. So I'll send you a video. The first one will be on pie chart. Then we do histogram, we do box plots, we do curves, and so forth. So we have to take each of them so I'll send you that. Please practice through. Then by the time we meet, we can do a test and then we move on. Yes. So the previous, the Wednesday class. I have it. I'll upload it. If I forget, please remind me. So, yeah, these are the graphs we will be dealing with, box plots, histogram, what else? Basically, this semester we want to be able to concentrate on these, and then the other semester we will do the model. So please date will be what? 20 something. 23rd. So I'll meet you 23rd, and I think that will be the last time I'll meet you. Then Dr. Sumar will be. Yeah. Yeah. That week I won't be around. So maybe when I come back, there's a need I may meet you. But he will also, we teach it together. I have to teach you functions, so next week we'll do functions and then we teach it together. We have to do it. Yeah, so that you can do your own, write your own functions. Please, any question? Yeah. No, this one, because the data is highly skewed, it's difficult to show. Yeah, you can do the graph and also do the descriptive one. The descriptive one now is better, sorry. The numerical one is better because now you see values in them. But if you draw a box plot like this, well, that's also good to show people that they are, all of them are right skewed. They have outliers and all the outliers are unusually large. There's no, sometimes you can have outliers which are unusually low. Is there any question? Alright, then since it is Friday night. The week hasn't been okay, so then we'll call it a night. So enjoy the weekend and please, yeah, take care.